Hello students, myself Amrita Dhar, Assistant Professor of Electrical Engineering Department of Greater Kolkata College of Engineering and Management, JIS Group. I will teach you Power System 3.
In this video, I will discuss about dynamic response and significance of double loop. These topics are under the topic load frequency control for single area. And this topic is included in module 3 of the subject Power System 3. Subject code is EE-703A. At first, I will do board work to make you understand about dynamic response of load frequency control for single area. Then I will describe the double significance of double loop over PowerPoint presentation. So let's start. To obtain the dynamic response giving the change in frequency as function of the time for a step change in load. The characteristics equation being of third order dynamic response can only be obtained for a specific numerical case. However, the characteristics equation can be approximated as first order by examining the relative magnitudes of the time constants involved. Typically, the values of time constants of load frequency control system are related as TSG less than TT less than very less than TPS. Now typically the value of TSG is 0.4 second, TT is 0.5 second and TPS is very high compared to TSG and TT, its value is 20 second. Now letting TSG and TT is equals to 0, TSG and TT is equals to 0 and there is another assumption KSG and KT is almost equals to 1. So the block diagram is this is 1, this is KPS by 1 plus STPS, delta F of S, this is delta PGS, this is delta PDS, this is delta PCS, and this is the feedback path. Okay. Now from this block diagram, delta PGS is equals to delta PC minus 1 by R delta F. And delta F of S is equals to PGS minus PDS into KPS 1 plus STPS. So now delta F of S is equals to, put the value of PGS, delta PCS minus 1 by R delta F of S minus delta PDS into KPS 1 plus STPS. So delta f of s is equals to 1 plus 1 by r kps 1 plus stps equals to delta pcs minus delta pds into kps 1 plus stps. So delta f of s is equals to kps by 1 plus stps by 1 plus kps by r 1 plus stps into delta pcs minus delta pds. Now delta f of s is equals to kps by 1 plus stps 1 plus stps plus kps by r 1 plus stps. Now cancel out this term. Delta pcs minus delta pds this is equals to kps, minus sign is here, kps by my 1 plus s tps plus kps by r into delta pcs minus delta pds. Now we can rearrange 1 plus kps by r plus stps delta pcs minus delta pds. So at delta f of s, delta pc s equals to 0, this is equals to minus kps by 1 plus kps by r plus stps into delta pcs. Delta pds, because pcs is equals to 0. Now delta pds is equals to delta pd by s. Now delta f of s is equals to kps, take common tps, so kps by tps is equals to s plus 1 plus kps by r into tps into delta pd by s. So minus kps by tps s into s plus rtps plus kps by rtps into delta pd. Here is tps r plus kps. Now we take a equals to R plus kps by R by tps, and this is another constant term, so the function is 1 by s plus a. This is equals to 1 by s minus 1 by s plus a. This equal to this. So inverse Laplace of this is 1 by a. Inverse Laplace of 1 by s is 1 minus e to the power minus at. F of t, that means inverse Laplace of delta f of t, that is inverse Laplace of delta f of s, is equals to 1 by a. A means RTPS by R plus KPS, and this is the constant term KPS by TPS into 1 minus e to the power t into a into t. So t and a is R plus KPS by R TPS. Delta PD. Now TPS is cancelled out, so we can write minus R KPS by R plus KPS 1 minus exponential of minus t by TPS R plus KPS by R. Delta PD. Now taking R equals to 3, typical value of R is 3, KPS, that is 1 by B, that is 1 by 0.01, this is equals to 100. The value, typical value of TPS is 20, delta PD is equal to 0.01 per unit. So by putting this value, delta f of t is equals to minus 0.029, 1 minus e to the power minus 1.717 t. So delta f steady state is equals to minus 0.029 Hertz. Now in this picture you can see that first order approximation and exact response of the system, and from this picture it is clear that first order approximation is a poor approximation. Here delta PD is equal to 0.01 per unit, TSG is 0.4 second, TT is 0.5 second, TPS is 20 second, KPS is 100 and R is 3. These are the typical value of these components. We have considered the simplified case of a single turbo generator supplying an isolated load. Consider now a practical system with a number of generating stations and load. It is possible to divide an extended power system, say national grid, into sub-areas, maybe state electricity board, in which the generators are tightly coupled together so as to form a coherent group. That is, all the generator responds in unison to changes in load or speed changes settings. Such a coherent area is called the control area, in which the frequency is assumed to be the same throughout in the static as well as dynamic response. For the purposes of developing a suitable control strategy, A control area can be reduced to a single speed governor, turbo generator and load system. All the control strategies discussed till now are therefore applicable to an independent control area. Next we discussed about significance of double loop. Now it is evident from our previous discussion that with the speed governing system installed on each machine, the steady load frequency characteristics for a given speed changer setting has considerable droop. Now in previous case we see that the steady state droop in frequency 2.9 Hz from no load to full load. Now the system frequency specifications are rather stringent and therefore so much change in frequency cannot be tolerated. In fact, it is expected that the steady change in frequency will be zero. While steady state frequency can be brought back to the scheduled value by adjusting the speed changer setting, the system could undergo intolerable dynamic frequency changes with changes in load. Now, the system could undergo. It leads to the natural suggestion that the speed changer setting be adjusted automatically by monitoring the frequency. For this purpose, a single from delta F is fed through an integrator to be the speed changer, resulting in the block diagram. Now you can see in this picture integral controller is added to the block diagram of the complete system. Now the system now modifies to a proportional plus integral controller, which is well known as control theory. Now which as is well known from control theory gives zero steady state error, that is delta F in this case is equal to 0. The signal delta PC generated by the integral control must be opposite sign to delta Fs, while the integral control must be of opposite sign to delta Fs, which accounts for negative sign in the block for integral controller. Now delta F of S is equal to minus Kps by 1 plus Tps into S plus 1 by R plus Ki by S into Kps by 1 plus STSG into 1 plus TTS into delta PD by S. Now this simplifies to minus R Kps S into 1 plus STT STSG into 1 plus STT by S into 1 plus STSG into 1 plus STT into 1 plus STPS into R plus KPS KPS into Ki R plus S into delta PT by delta S. Now obviously if the value of S is 0, then delta S into delta F of S is equal to 0. We can see that the steady state change in frequency has been reduced to 0 by addition to of the integral controller. Now if central load frequency control of a given control area, the change error is frequency is known as area control error. So this is the significance of double loop. Now you can see in this picture, without integral control action the change in frequency is much higher, and with integral control action the change in frequency is equal to 0. Now this picture shows dynamic response of the load frequency controller with and without integral control action, where delta PD is 0.01 per unit, TSC is 0.4 second, TT is 0.5 second, TPS is 20 second, KPS 100, R3 and Ki is equal to 0.09. And from this picture it is clear that without integral control action the change in frequency is much higher, approximate 2.9 Hz, and with integral is much higher, and with integral control action the change in frequency is equal to 0.
That's all from today's class. If you have any problem, please contact with me. My contact details is given on the first slide. Thank you.